Hey guys, welcome to this video on continuous random variables. We have touched on continuous random variables or the notion of continuous random variables in the discrete random variables video, but in this one we're going to go into a little bit more depth and how we actually start to organize and display that data. So for a continuous random variable, we're still going to use the sign X. So capital X again. And what the values of it, which we're going to signify as little x again, can take on any real value. So there can be any real value. And that means that it could be 7.3654, it could be 7, but generally it's going to be within a particular range. So we should start off by talking about that the probability that a continuous random variable is exactly equal to a particular value is 0. So if I was to write it out, the probability that x is going to be equal to, let's go 33.7, it's always going to be 0. And the reason for this, if we were to, let's say that this is the height of a seedling. If we were to measure the height of the seedling, well, what device we're using to measure it has a level of error associated with it. So the rule, say if we were measuring with a ruler, generally that's got millimeter markings. But what if this seedling, and I'm going to draw it really badly here, had its marking halfway between, so that's 1 millimeter and that's another, and what if the marking was partway between them? Well, it's not exactly 33.7, we're just rounding, so that's why it can never equal 0. So for continuous random variables, we talk about the probability that x lies within a particular interval. And what this interval is, let's say we're measuring the heights of trees. We might talk about the interval being between 33 centimeters and up to 34. Another interval might be from 34 to 35. So each of these are intervals. So we could then use these intervals to create a frequency table and then plot them on a graph which is called a histogram. So you may be familiar with a frequency table. What it is, we have the different intervals. So we might have height, and we've got interval 1, 2, 3, 4, 5, etc. And then the frequency. And what the frequency tells us is how many times, if we're measuring a bunch of seedlings, then the interval for this height here, let's just call them, let's go 29. Now these actually shouldn't be zeros, they should be x's, capital X's, to 30, 31, 30 to 31, etc, etc, etc. So I do apologise for not getting that right. Let's go back and fix it. 30, 31, etc. As we go down, then we might find we've got 5 in that interval, 2 in that interval, etc, etc, as we go down. And then we can have a total at the end. And let's say that we measure 55 in total. So all the frequencies should add up to 55. Then a histogram is much like a column graph, except there are no gaps between the columns. So if I was to quickly draw one out, then each of these columns would represent one interval. So we'll have up here the frequency, and along here we've got x, which is our intervals. And that's really it for how we display continuous random variables and what continuous random variables are. Let's look at a full example now. So if you need to get any of this down, pause the video and we'll continue on in a moment. Alright guys, welcome back. Now I've drawn up here a set of data, and what this is the heights of 80 randomly selected school students, and this is the intervals. So the heights are our intervals from 150 up to 160, 160 up to 170, etc, etc, and the frequency at which they occur. So out of those 80 students, we had 14 in the that were between 150 and up to 160 centimeters tall. From 170 up to 180 centimeters, there was 30 students. So if we were to draw a histogram of this, then we'd really be just drawing a column graph without any gaps. So to draw it up really quickly, we'd have 150, 160, 170, 180 and 190. And if we go up by 5s, 5, 10, 15, 20, 25, 30. So let's put some labels on this, like we should. Along here, height. Okay, so between 150 and 160 there was 14, so that's roughly about there. So we're going to have a column there. 26, which is roughly about here. Now, in a book where you've actually got lines, you can get it more accurate. I don't have lines here, so it makes it quite difficult. So next one's at 30. And the final one is at 10. And that's a histogram there. So the next part is we're going to look at the relative frequency. And what the relative frequency tells us is if we add all the relative frequencies together, we're going to equal 1. If we were to multiply the relative frequency by 100, we'd get the percentage. So the way that we work out the relative frequency is the frequency, and we divide that by the total. So in this case, we're going to have 14 over 80, which is going to equal 0.175. 26 over 80, which is 0.325. 30 over 80, which is equal to 0.375, and finally 10 over 80, which is equal to 0.125. Now if you add all of these together, they'll equal 1. So now we can estimate that the probability that a randomly selected student is between certain ranges. So let's say we've got the question, estimate the probability that a randomly selected student is between 150 and 160 centimeters tall. So we're looking at this first one here. So the way that we're going to write this is the probability that we're going to have 150 to 160. Now, you notice that we're using h here instead of x. It does depend on what you're doing. In this example, we use h because it represents height. It kind of makes sense to do it that way. Generally, we would use x though. So it's just one of those things. Alright, so probability that they're between those heights there, well, we just use our relative frequency, which is just equal to 0.175. Now, if we wanted to find that the student is taller than 170 centimeters, we would write it as the probability that height is greater than 170. And in this case, what we do, we get our relative frequencies for 170 to 180, and we add to it the relative frequency from 180 to 190. So what that's going to be equal to is 0.375 plus 0.125, which is roughly equal to, well, in fact, it actually is equal to 1/2. And that's what we've got. So that's really it for the continuous random variables section. We will look at the density functions and those as well for continuous random variables. So if you've got any questions, just ask. As always, thanks for watching, and we'll see you next time.